Hi everybody, today we are going to be talking about lesson 1.7, which is piecewise functions. This is in your lesson 1 notes. We're going to talk about several things: evaluating, writing equations, and graphing. So all those things are going to be included in today's lesson. So first of all, evaluating. Do these, first of all, before we even talk about that, do they fit the definition of a function? If you look at these two functions, are they functions? What do you think? They are both functions because they both pass the vertical line test. Remember, if I took a vertical line and passed it along, it would only hit the graph one spot anywhere I go. So this one passes the vertical line test, and if I come over here, it also passes the vertical line test. And we've talked about before how these two are kind of overlapping, but the one that has a solid dot is there, and if it has an open dot, it's not actually there. So this also still does pass the vertical line test. So yes, both of these are functions. However, there are special kinds of functions which are called piecewise functions. So if we're going to evaluate piecewise functions, that means when you plug in a number. So what is f of negative 3, what is f of negative 1, and what is f of 2? And we've done this in class before, and this first one is pretty straightforward. So you should be able to do this. Pause the video for a second and see what you come up with for negative 3, negative 1, and 2. Okay, so remember that the number that is in the parentheses is the x value, and they are wanting to know if that is negative 3, then what is the y value? So negative 3, negative 1 is right here. If we go to negative 1, we hit here at 1. This one might be a little bit tricky because this line is not a straight line, it's kind of curved. I estimated it at 4. I think if we go to 2, we're going to hit right up there at 4. So that's how I came up with that one. The next one is, again, a little bit tricky, not too terribly tricky, but we can do it. G of 0 is just 0, of course. I mean, it hits right there at the origin. G of 1, okay, so first of all, wait a second. Let's look at how we have this graph lined up. So this is 0 and this is 2. So it means that's 1 and that's 3. And that's 1 and that's 3 and so forth. So we're counting like 2 boxes for each one. So G of 1, here's 1. And that is here at 1. So that is 1. And G of 2, well, that hits right here, and we have to decide which one to choose. Remember, we always choose the one that has a solid dot. The solid dot is at the 3. So there we go there. So that is evaluating piecewise functions. We've covered that a little bit, but a couple tricky ones I wanted to make sure we touched on today. All right, for this next concept, we are going to then write an equation for the piecewise function. And you know what? I know this has f of x. Let's change it to g of x. We called this one g of x, remember? And this one f of x. So let's change this to a g of x. So I want to use this function as an example. Notice that there are 3 pieces of the function. That's also over here we have 3 pieces of the function. And if we look at them, we can define each section, and we will do that here in just a minute. But before we do that, when we have a piecewise functions, because there are 3 parts, we're going to have like 3 separate equations, but it's going to say when does it have that, when does it meet that requirement. So for instance, for these 3 separate parts, I'm going to erase some of this. All right, I do want to keep on there though that this is a 1 and this is a 3, just so we remember where things are. So we have this first piece of the function, and it's everything less than 1, right? Anything less than 1 is this part of it here. So I'm going to say if x is less than or equal to 1, and I included the equals because the dot is solid there. The next piece is right here. It's between 1 and 2. So between 1 and 2 means 1 is on the lower side, 2 is on the upper side. The 1 does not have an equal to with it, but the 2 does have an equal to with it. So this expression, 1 is less than x is less than or equal to 2, represents the area where this one is, the interval where this one is. And then the last one is from here, it's from 2 on. So if x is greater than 2. So those are the 3 parts. Now we have to look at each of those 3 parts and figure out what is the equation that matches what's going on there. So this function here, I don't know if you can tell, but actually it is a parabola. So if we could continue this up here, right? This is a parabola, but it's only a piece of a parabola, and so that's why we have this if. So this is a parabola. It is centered at 0, 0, and so that means, and it also goes I know that this equation is just plain old x squared. It's not plus anything, it's not minus anything, there's nothing in front of it, it's just x squared. Then the next section is this little line segment here. The little line segment, that's a 3, is the equation is y equals 3. So here y is just 3. Anytime it's between x is between 1 and 2, y is 3. And then finally this segment here, which is a straight line, and if we continue it on, we might be able to see that it also has an x-intercept of 0, and it goes up 1 over 1 for my rise over run, and so that is just plain old x. Okay, so let's just take a look at the 3 sections. So our 3 sections, it's x squared, that's a parabola, when x is less than -1 or equal to. It's 3, this flat line is y equals 3, when x is between 1 and 2, including 2 but not including 1. And it's just an x, like 1x plus 0, when x is greater than 2. So this is a function that would match this piecewise. You ought to be able to look at a function and come up with a piecewise equations to match it. And we'll do some more practice on finding the equations like that in class. So if you're feeling like you're not really there yet, that's okay. We will work on it together. Okay, for the last concept, concept 3, we're going to do kind of the opposite of what we just did. We're going to graph this function onto this graph. So there's a couple things we need to do. First of all, notice there are 3 sections again. In all of the examples today, there have been 3. There could be 2, there could be 4, there could be 8. I'm just doing 3. So it just depends on the function. So there are 3 sections here. Each section has its own rule, and each rule has just the own interval where we're going to actually do that. Let's take a look at the first one. So y equals 1, that is a horizontal line at 1. So it's just going to be a horizontal line along here at 1. However, it's not everywhere. We need to do some erasing because it's only when x is less than -3. So I need to erase this and say nope, only when it's less than -3. And that -3 has an open dot because it does not have an equal. So I'm going to put an open dot here. And so this part of the graph, this piece of the graph, is going to look like this. The other pieces are looking a little bit more, they have a little bit more going on. So for that, I'm going to make a table of values. So for this middle piece, I'm going to make a table of values. I'm putting that table over here. It says x minus 1 if x is between -3 and 3, and we have equals on both of those. All right, what I want to do is in my table, I want to put those 2 numbers. I want to put in the -3 and I want to put in the 3. I also, since they have less than or equal to, I want to put a solid dot to remind myself that's how I graph those, is with a solid dot. And then lastly, I want at least one other point. I might have more than that, but at least one other point. So I need to pick a point that's in between here. Well, in between -3 and 3, I know 0's in there. That's an easy one to pick, so let's do that. Now I need to plug those in to this function. So -3 minus 1 is -4. 0 minus 1 is -1, and 3 minus 1 is 2. I'm going to now take these points, I'm going to plot them on my graph. So -3, -4 with a solid dot, 0, -1, also with a solid dot. I didn't say it, but anything in the middle is definitely going to be solid also. The 2 endpoints you need to be careful about, but that middle one, that's always going to be solid. Okay, and then the last one is 3, 2, so I'm going to go over to 3, 2, and I'm going to plot that point. I can connect those dots, and I don't need to erase anything. On the last one I had to erase because I drew too much. On this one, I had the endpoints defined, so this is what it is right there. I'm on my way with my piecewise function. My last piece is this one, so I'm going to do another table of values. So again, for my table of values, I want to look at the interval where it's defined on. It is defined if x is greater than 3. So that means I can do anything greater than 3. 3, 4, 5, 6, whatever. And my 3 needs to have an open dot, so I'm going to put that there to remind myself that's supposed to be an open dot. Now I need to take each of those, plug them in, and find my y. So I'm going to plug them each in, 2 times negative 3, that's negative 6, plus 4 is negative 2. If I plug in a 4, I get negative 8 plus 4 is negative 4. If I plug in a 5, I get negative 10 plus 4 is negative 6. Okay, so now I can plot these points. Remember I said anything that's not on the end point will be a solid dot. Okay, so 3, negative 2 is an open dot. 4, negative 4 is a solid dot. 5, negative 6 is a solid dot. And so now I can connect those points going down this way. And it goes forever because it says it's greater than, so it's going to go on forever there. So this is my piecewise function. I divided it up into the 3 parts. One of them I didn't need a table because it was just 1, but I had to do some erasing. The others I did a table, and I made sure I had my solid dot and open dot, and I did my graphing from there. This is just an introduction. We are going to do more practice of this in class. Take a minute right now to write down some things that you might want to remember, and we'll go over that in class as well.